welcome to AP Stats 9.2. Take out your notes. We got to get cracking because I doubt we're going to get through all three of these examples here today. Happy Friday. I'm talking to you. Happy Friday. Go on out. Do something special this weekend. All right. Get me something nice. All right, here's your perfect little phrase I taught you guys yesterday. If the p-value is low, the null must go. If the p-value is high, the null will fly. All right, this tells you if your probability is lower than the significance value, then the null must go. If the p-value is higher than the significance value, the null will fly. So, just a nice little thing to write down. Here we go. By the way, I'm in the makerspace. Kind of looks nice, eh? I'm using our fun little sprout, testing it out. All right, here's a little fun fact. You didn't know it, but I've been collecting data on our two truths and a lie. Yes, that's right. I was curious to see if people truly randomly put their lie in any place on two truths and a lie. And I did 34 people, and I noticed 18 of them put it last. They put it last. The lie was last. Curious. Did I collect enough samples, though, to say most of my students put their lie last? Or that's where it's most frequently. All right, so we're going to do a four-step process. So state. All right, we are going to use a significance level of 5% to do our test. And we're going to use the four-step process. So, my statement. I will do a 5% sig test. All right, I could probably write that a little bit more in detail, explaining, but I am limited on time, so please feel free to pause the video and put a little bit more detail, maybe saying to see if students tend to put their probability or tend to put their lie more on the last one. Now, we also put in the statement, this is where we put our HO and our HA. All right. So in this one, we've got to realize that I took 34 people and I realized that 18 put it on the last. So that is a probability, correct? A probability problem. And notice we're only doing proportions here of 18 out of 34. Hold on a second. I'm going to go grab a calculator. I'm back. It's 52.9. 0.5294. Wow, that seems a whole lot more than what it should be. All right, so my hypothesis. Well, it should be where? What is my hypothesis? It should be, well, I have three options, and it should be in one of those. So the third option should have a 1 in 3 chance, which I could say is 1 in 3, but let's be a little bit more specific and actually go 0.33. We'll say the repeating. It should be 0.33, right? I have a 30% chance of it being on the last one. However, I think it might be bigger than that on the last one. I think the probability is bigger on the last one, so I think it's bigger than 0.33 repeating. That's my guess. All right, so that's my statement. All right, let's do my plan. You guys love your plan, don't you? You just feel warm and fuzzy doing your normal test, right? And your in-deep test, oh man, shoot, I started to do Indy. Oh, great. Normal, independent, and then random. You want to make sure all those are stated. Is this normal? And remember, I'm dealing with P. And P is 10 successes. and 10 failures? Did I do 10 successes and 10 failures? Well, I definitely got 10 people. I had 18 people who put it last. And so I have 10 successes. And then, sorry, a lot of people interrupting me. 10 successes, and then I also have 10 failures, right? Because I have 18, and that means I must have 16 people who didn't put it last. All right, now my independence test. Well, here's the key. I actually don't even need to do the 10% or less than 10% of the population, because notice in here, in the statements, I say participants were replaced. So that means I could have had the same person do it twice. I might even had one person do 2 truths and a lie 3 times, right? So really, when you think about it, the population is just endless, because I could just keep having people do it over and over and over. So the independence test, it is independent already. I don't need to do the 10%. As soon as I start replacing things in, that's independent. And then random, did I choose them randomly? And yes, I did. So those are your plan. All right, now here's the fun part, your do. All right, and your do is your z-score. That's all it is. So it's what I got, which I believe was a 0.5294. All right, I'm going to do a little z-score on this baby. Minus what I should get. What should I have gotten? 0.3333, right? All over my standard deviation. Now, here's the tricky part. I'm going to draw a little normal curve over here. My center of my normal curve, I'm assuming, is 0.33, correct? So which probability am I putting in for my standard deviation? Am I putting the 0.52 or am I putting in the 0.33? Right? Think about it. Because on confidence intervals, I only had the 0.52, so I had to put 0.52 in. But I'm assuming it's 0.33 is the curve, so I have to use that as my standard deviation. All right, times its inverse, which would be 0.6667. All over, and then how many samples did I do? 34. All right. Okay, let's have some fun with this and calculate it out. All right, so after calculating out, I got a z-score of this. Now remember, my significance level is at 5%. So that means I want, what in tarnation? Okay, it means that I want, okay, if it's in this little area that holds 5%, I'm going to reject that sucker. All right, so if I look at 2.5 or 42, where is this located? And I actually get a p-value, or my probability of this event happening is actually 0.0076. All right, now I did this in my calculator, and if you're smart, you might be able to figure out where it is. Otherwise, I'll talk to you about on Monday on how to find it in your calculator. But I got a p-value of 0.0076. Now, is that higher than my significance value or lower? And that means it's lower. So that means I'm located over here somewhere. It is lower. So the null is low, or sorry, the p-value is low. So my conclusion, reject the null. Period. Let's put it in the context. Students appear to put their lie last more often. Okay? You might be able to write that a little bit better too, but in conclusion, I can clearly see, all right, just from 34 people that I collected, it seems like people put their lies last. Now, here's where the psychology part pulls in. Bring the story problem to Mr. Ward and see, why do you think people tend to put their lie last? I wonder, is it because they can think of truths for easily, and so they think of two truths first, and then that's the lie is what they really have to think about? I don't know. Kind of interesting. All right, we're going to do one more. I don't know if we're going to get through two more, but let's do one more here, and we'll try and do a two test maybe on Monday, two-tailed test. On shows like American Idol, contestants often wonder if there is an advantage to performing last. I've always wondered that too, because that's the one that's fresh in their mind, right? To investigate this, a random sample of 600 American Idol fans is selected. That means equals N, right? Okay, they are showing the audience tapes of 12 never-before-seen contestants. Each fan order of 12 videos is randomly determined. Thus, if the order of performances doesn't matter, we would expect approximately this much, right? Okay, we'd expect a 1 in 12 shot if it doesn't matter. In this study, 59 of the 600. So my sample, I think I messed that up the other time. I don't think I put the p hat on, so you might want to go back to the old lesson. I get 0.0983. All right, 0.0983. That's 59 out of 600. Is my sample. Prefer the last contestant they viewed. Does the data provide convincing evidence that there is an advantage to going last? Now, on my statement, I'm going to cut some corners because I'm just going to jump right to my hypothesis. You can state some other stuff, all right? All right. I'm going right to my hypothesis. And we're going to assume that my parameter, or my proportion, equals 1/12, which what is 1/12? 0.830, sorry, 0.0833. So that's what it should be, 1/12. I'm going to see if my proportion is actually greater, because it says, do they have an advantage? So I want to see if it's greater than 0.0833, because I think going last, hey, this is a good situation. Another kind of problem you could do at the end of the year. All right, we'll go through plan. Don't forget to do your plan. I'm not going to do it. I'm just going to keep going. All right, let's go to do. Remember, your plan is normal, independent, random. All right, do. So what I got, 0.0983 minus what I should have gotten was 0.0833. Okay, all over my standard deviation. Now remember, which standard deviation am I assuming I'm using? Well, I'm assuming it should be at 0.0833. So I'm using 0.0833, and my pen is getting a little. All right, I'm going to calculate the rest out here and a z-score for you, and I'll be right back. All right, back. And I got a z-score. Notice this is what my z-score looks like. I got a z-score of 1.33 roughly. Now I'm going to have to round. So my p-value is going to be slightly different than yours. Okay, and my p-value is 0.0913. All right, now where was I drawing the line? Where was I drawing the line? Let's go back up here. It doesn't say, does it? I don't see anywhere where I'm drawing the line. Well, if they don't tell me where I'm drawing the line, what is my number? I should probably, oh man, this thing. I should probably use the good old faithful 5% is where I should draw my line. Now my p-value is higher than 5%, so the null will fly, meaning conclusion, there's not enough evidence to say that the person performing last actually has better odds of being chosen. Cool. All right, we will do the two-tailed test, which is the next one on Monday. Start working on some homework, and have a good day.